So what is a right outer join? Now we've talked about inner joins and left outer joins. Does it mean there might also be a left join, a right join, or a right outer join? Well, yes. For starters, left join is short for left outer join. Right join is short for right outer join. And join is short for inner join. To clarify the language of join statements, it's important to understand that left corresponds with the first table in any join clause. Now, remember this query from the previous video? Select book.title, author.name from book, left outer join book author on book.id equal book author.bookfk. Left outer join author on book author.authorfk equal author.id. When you have from book, left outer join book author, book is the left portion of the first join, and book author is on the right. You could also say the book table is joining into the book author table from the left-hand side. In the second join of that query, book author is now on the left and author is on the right. And in that situation, book author is joining into the author table from the left-hand side. We commonly read queries from top to bottom, and there are exceptions. Because the left outer join always brings in all values from the left, i.e. the top, while the values on the right are optional, it's easy to see left outer joins as being top required and bottom optional. Now, looking at the query above, it says that book rows are required, but book author rows are optional. And reading a top to bottom paradigm as required/optional is quite conventional with many ways that we perceive things. For example, clicking an element at the top of a UI can optionally show detailed information below it. A right outer join flips that on its head. Because the right side of the join is on the bottom, a right outer join would mean top bottom is optional required. If that confused you, go back and listen to the previous section again. It's important to point out that if you swap the order of things, a left outer join can be rewritten as a right outer join. For example, select book.title, author.name from author, right outer join book author, and author.id equals book author, author.k. Right outer join book on book author.bookfk equal book.id. This query means the exact same thing as the previous one. Even though it looks like it was twisted inside out, it will produce the same results. Author is joined with book author, but because it's a right outer join, the book author rows will be matched against optional author rows. But don't overlook the fact that book author is right outer joined with book, meaning all book rows will be matched with book author rows. This makes author and book author optional, while the book rows are required. This is why you'll tend to see enterprises favor left outer joins over right outer joins. This example of right outer joins pushes us to read the query starting at the bottom, which goes against the grain. We're used to reading things from the top. But this isn't simply because our native tongue probably reads from the top of the page. The projection of the select clause is always at the top. Reading the projection at the top and then jumping to the bottom to read all the joins requires us to do a lot of mental skipping to hold all that together. Also consider the fact that this example query is relatively short. What if we were dealing with a 3-page query? I did see one example of someone using a right outer join, but that involved a query that had already been developed that was quite extensive. Most of the query used left outer joins, but later in the development of that query, after much work had been invested in it, the op realized they needed one additional join that was a required field. Instead of attempting to rewrite the whole thing from scratch, they simply tacked the additional join on at the end. There are situations that need right outer joins, but they tend to be the exception. Now, perhaps this convinces you to prefer left outer joins over right outer joins. But what about left outer join versus just left join? I mean, after all, they mean the same thing, right? For me, the outer token helps me see that this is an outer join faster and that the table we're going into is optional. It's the same reason I prefer using simply join instead of inner join. One less token for me to visually parse. If I saw left join and inner join all over the code, the coherence between the two is diminished. There are 2 tokens in every join, so I must hone in on the first token to discriminate. Additionally, one is 4 characters long while the other is 5. That further slows my visual parsing ability. Yes, one of them starts with L and the other with I, and even these letters look quite similar. However, if I see join and left outer join everywhere, then I can quickly see the singular join token and quickly spot this as an inner join that's required. And when I see left outer join, the left outer tokens serve as a qualifier that my brain turns into optional, and I'm done. Maybe that sounds confusing. Maybe not. This was actually a style I learned from someone that had been doing database design for years before me. And after 10 years of reading queries on that contract, this standard became easy to visually parse. Join equals inner required values, while left outer join equals outer optional values. And to be honest, after writing over 200 queries, I never once wrote a right outer join, if that helps. To round out the subject of various types of joins, I want to share that there's also a full outer join. It's still an outer join in that optional rows are brought in. Full means that results aren't confined to left or right. Instead, this join will bring in all rows from both sides of the join. The values from the left side, the top, are optional, but so are the values from the right side or the bottom. Basically, both sides are optional. A situation I struggle to find a meaningful example. Online examples I've seen combine customer data with orders. This means that you have customers without orders as well as orders without customers. A full outer join would show you both all at once. But can you imagine a real world situation where this would happen? I've never written a full outer join to solve a problem, nor stumbled across a scenario where neither join nor left outer join didn't offer what I needed. And I've yet to meet anyone with such a problem. Do you have a query that fits that? Leave a comment if you do. Writing queries and joining multiple tables, each filled with perhaps millions or even billions of rows, and producing a practical result set requires that you understand the Cartesian product.